6.5, Logarithmic Functions, Properties of Logarithms. Well, we've already talked about what a log is. It's just an inverse of an exponential function. If you've watched the last video, you heard me say logs have the same properties of exponents. Since they're a way to solve for exponents, they carry all the traits of exponents. So, this is just a review of switching between log form and exponential form, and we've also talked about how a common base is log base 10, and log base e is just a natural log. Well, let's talk about properties of logs. Like in properties of exponents, anything raised to the 0 power is 1. Well, logs are inverses, so a log of 1 will always be 0. Think of it this way. This was x was 0, we got y was 1. Well, here, logs equal the exponent, so that, because logs are like inverses, so I don't want that to confuse you though, so let me clear that off and let's just keep going. So anytime if it ever says log of 1, the answer is always going to be 0. Well, exponents, when you have the same base, to multiply, the base stays the same and you add the exponents. Well, logs have that same property. If we're multiplying inside of a single log, you can split that apart and it becomes addition of two separate logs. It's just like adding the exponents, because logs are exponents. And it doesn't matter whether you're log base 10, a log base e, or any log base. It still has those same properties. If we're dividing, likewise if we're dividing, you subtract exponents. Well, if you're dividing logs, it's dividing in a single log, you subtract separate logs. And a power to a power, we actually multiply the powers together. Well, on logs, you can take that out front and multiply by that power. So the power gets moved out front and becomes a multiplication problem. Same thing on any log. And just to review, if you ever have a denominator that has a power, you can move it back to the top and that's a negative power. And likewise, if it was negative on top, you can move it to the bottom. And the other trait here is a root is a rational power, so it's a fractional power. We write it as a fraction. So, some other traits of logs that are very useful are if the base of the log and the base of your main argument are the same, the exponent will be your answer. Because this in exponential form would have said 10 to the power of something, like if this wasn't given, we were trying to solve for it. 10 to what power equals 10 to the x power. Switching from log form to exponential form. Well, if the bases are the same, the exponents have to be the same. That works for any log. If this and this are the same, the exponent will always be your answer. Likewise, there's a nifty little trick. If the log is the exponent and the base of the power and the base of the log are the same, they like cancel out and you're left with just whatever it was a log of. Like this one right here. B raised to a log base b will cancel and leave us just whatever the power was. And same thing on e. Natural log means base e, so if those are the same, you end up with that for your answer. So let's actually practice some of these. So to start off with, let's review a little, switching between forms, because that's on the assignment also, to write it in exponential form. So it's going to be this base to this power. This base, when there's an understood 10 there, 10 to the power of y equals 8. And that's all we have to do on that one. And number 2 wants us to go the other way around. So we're going to switch this into a log. So it's a log of, this is your base, 4/9. Logs always equal the power, and so 2/3 would have to be right here. It's a good habit to put a parentheses around it, especially when there's more than one thing there. Number 3, we want to evaluate this logarithm without a calculator. So our goal in a problem like this is we want to try to write it with the power, so we can use, if possible, one of these power rules. Let me clear off all my scratch work here. Like we want to be able to get where it's like this kind of a problem or this kind of a problem. If these two things are the same, we can get the answer. And that's the reason I show you that, because log of 1,000 is a log of 10 to the 3rd power. Well, this right here is an understood 10 that you don't have to write. But if these two are the same, there's your answer, because it's saying 10 to what power equals 10 to the 3rd power. 10 to what power equals 10 to the 3rd power? Well, it would have to be 3. So the answer is 3. But you don't have to write all that, because you can just look at it and go, there's the answer. And number 4. We've got to rewrite this one, and it's a natural log. So if we rewrite this one, we move that back to the top. That's natural log of e to the negative 6 power. Well, natural log is log base e. If these two are the same, the power is your answer. So the answer is just negative 6. And let's move on to number 5. So we want to evaluate this log without a calculator, but I'm going to rewrite this as a power. So log base b of b to the, well, that would be a 1/5 power, because that's a root. So a root is always, what the root was by denominator of the power. If these two are the same, there's our answer. So 1/5 would be the answer to this problem. So you'll be able to look at these to get a lot on your assignment. Some of these go pretty fast. Like this one, 64 is actually 4 cubed. But that's in the denominator, so this is the same thing as saying log base 4. A 4 to the third would be 64, a negative would move it to the bottom. So that means the answer to this problem is negative 3. For number 7, it says use the product or quotient and power rules of logarithms. So that's where when you're multiplying, we added, turned it to addition, and when it was division, it became subtraction of separate logs. Well, we're going to use all that and put this back together. So our goal, as long as these logs have the same base, we only have to write the base one. So let's talk about a number in front. How did we get a number in front? Well, if we look back on our front of our here, when did we have a number in front? Here or here? It was when it was the power. So we're going to move that back to the power. So, I'm going to clear this off and go to the next page and clear that one off too while I'm at it. So, number 7. So this was a power. So this is, let's rewrite them just as powers first. Log of x to the 2/3 minus, that becomes the power. So log of y to the 6th plus, that one's power would be log of z squared to the 1/2. Which, those are both powers now, so 2 times 1/2 is just z to the 1st. Okay. And we're going to write log. You should only write log once. And we have to remember what's subtraction meant division. So we're going to have x to the 2/3 divided by y to the 6th. And addition meant multiplication. So multiplication will be back up on top. So z, and that's all we can do to that one. So that is our answer. And number 8, we're going to do the same thing. But this one gets slightly trickier because there's some simplifying we can do, some properties of mathematics. So we're going to move this back to the power. So that is log base 5 of 27x to the 5th, both raised to the 2/3 power, plus log base 5 of 9x squared, both raised to the 1/2 power. And remember, a 1/2 power is a square root. So let's talk about, our goal, addition becomes multiplication, so we can actually multiply, I'll put this as log once, and it's going to be, and a power, you can distribute a power when there's no plus or minus. So that's 27 to the 2/3 times, what's that, about to put a 5, x to the 5th to the 2/3, which we multiply, when you're a power to a power, it just becomes 10/3, times 9 to the 1/2, times x to the 1/2 times 2 to the 1/2. So that's just 2 times 1/2 is just 1. Now, I'm looking inside here, and I see multiplication, which means I look for like terms, we can add them together if they're the same base. Well, 27 is actually 3 to the 3rd to the 2/3. So that's just 3 squared, which is 9. And this is 9 to the 1/2 is just 3. So right now we have 9x to the 10/3, and we have a 3, and we have an x to the 1st. I'm going to put that here, x to the 1st. So that's a log of all those things, and I just ran out of room. So I'm going to write all this down here below it, and I'll clear off the screen for the next one. So this is 9 times 3, which is going to be 27. So log of 27, and this is x to the 10/3 times x to the 1, which is x to the 10/3 times x to the 3/3, because we add exponents, so we have to get a common denominator. And 10 plus 3 is 13/3. And that is your answer to number 8, not number 10. So let's clear this off so that we can do number 9 and 10 now. Well, number 9 was written together, and we want to split this one apart. So we have to think we're multiplying this and this, so that means we're going to have a plus between these for separate logs, and we're dividing. So let's start trying to do that. We've got log base 3 of x to the 4th, but remember a power gets moved to the front. So that's going to actually be 4 log base 3 of x. And multiplying becomes addition, so plus log base 3 of z squared. Well, the 2 gets moved to the front, so that is plus 2 log base 3 of z. And we're dividing, so that's subtraction, and that's 3. I gotta look at my notes. That's 3 to the 4th. I didn't label that one very well. You can't tell if it's the 4th root. Oh, it is. It is the 4th. This is the 4th root of y to the 3rd. So I need to talk about this. So this is minus log base 3 of 3, and then I should have been writing that here. Log base 3 of 3, and we're dividing again because this one's on the denominator, so that would be log base 3 of y to the 3/4 power to write a fractional power. So remember the power gets moved to the front, so minus 3/4 log base 3 of y. And that would be a good answer, except I see one thing right here. Log, if these two are the same, the exponent's your answer, and when the exponent's understood 1 there. So this is 4 log base 3 of x plus 2 log base 3 of z minus 1 minus 3/4 log base 3 of y. Okay. We'll look at number 10. Number 10 is using that property that if the base of the property and the base of the log, whoops, and that's a pi. If these two things are the same, that all basically goes away. This will be your answer. So pi is the answer to this problem. You can look at it and see that answer. And let's move on to number 11. So for number 11, it says use properties of logs to simplify. Well, we've talked about how if the power is a log with the same base, it'll cancel, but that only works if it's a single log. So let's talk about this base, this power up here. We have log base 7 of x. Adding separate logs is the same thing as multiplying the same log. So that'll cancel and leave me just x times 8, or 8x, and that's the answer to that one. And finally, suppose that natural log of 3 is a and natural log of 7 is b. So we want to get everything in terms of natural log of 3 and natural log of 7 for this problem. And we're going to use properties of logs to rewrite that. Well, you could try to subtract this, but then I'm going to have a natural log of 2, like a natural log of 126 minus natural log of 2, which is not what we had here. So let's try a different method. Let's see, can you divide 126 by 2 first? Let's do that. And that gives you natural log of 63. Well, 63 is closer to using 3 and 7. Well, that's natural log of 63 is 9 times 7. And 9 is 3 squared. So we're using that property now. Multiplication of a single log is addition of 2 separate logs. And we can move this out front. So it's 2 natural log of 3 plus natural log of 7. And 2 natural log of 3 was a, so it's 2 times a plus natural log of 7 is b. So 2a plus b would be the answer to switch this in terms of a and b. And that is what you need to know to be able to do assignment 6.5. Good luck.